Vector multiplication. Vector multiplication. This vector multiplication. Today we will cover, we will explore what is a vector multiplication and what are formulas regarding this topic. This is a separate topic of vector chapter. We are exploring it separately. I am not starting this from meaning of a vector. No, I want to start with a discussion of vector multiplication. Vector addition we have seen in separate lecture. Vector subtraction of two vectors we have seen. Now it's a time to explore vector multiplication. Vector multiplication. Look at over here. This vector multiplication, it is divided into two parts. It is divided into two parts. First, a scalar product, and second we have vector product. In both cases, we are multiplying. Okay, we are not adding, we are not subtracting. When we will be talking about a scalar product, it means we are multiplying something. We are multiplying vector. When we will be talking about a vector product, here also we will be doing multiplication. Difference between them is when you are multiplying two vector, okay, two vector. This dot is a sign of multiplication for us scalar. So vector multiplication vector, and it is coming, a result is coming as scalar. It happens a lot of times. We take two vector and we are going to multiply. But result is coming, which is result is a scalar. Result is a scalar. Whereas vector cross vector, it is equal to result is the same vector. These two things will happen. One thing can happen. We are taking vector and this vector is being multiplied by another vector and result is coming as scalar. So this, if you are adding, if you are multiplying two vectors and result is coming as scalar, this is known as a scalar product. Okay. Whereas in other side, we are also taking two vector, but in this case we will see after multiplying two vectors we are getting again vector. So this type of view is known as vector product. Okay, vector product. One thing, this vector product is also known as a cross product. And this scalar product is also known as a dot product. Okay, dot product. Either you can call it as a scalar product or dot product. Either you can call it as a vector product or cross product. It's your choice. Let me give an example. This force dot is displacement. As you know, work is equal to if force multiple displacement. Definition of work is what? Force will be applied on a box, and that box, when that box will cover some displacement, in that case we can say yes, there is a work in the language of physics. Same here, force is our vector, displacement is also our vector. Now we are going to multiply both vectors. Result would come, I think, work 1. But it is said that work is not a vector. This is a scalar. So this resulted is a scalar. Okay. This resulted work is a scalar. here over here. This was an example for a scalar product. Now for this r vector cross f vector will be torque, will be torque, will be torque. So symbol of a torque is like this. Here you can see this r vector multiple force vector. I think so. It should be uh, rotation. Right now I am considering it as a so r vector multiple f vector. A result is coming torque vector. Okay, torque vector. Here multiplication of this both vectors, result is coming as again vector. So this type of example is called vector product or cross product. This type of example is called a scalar product or dot product. Do you understand till here? Till here? Now let's proof what is the logic behind this. We are doing multiplication this two vectors, then we are getting this over not with direction. What is the logic behind it? What is the logic behind it? One thing tell me a vector dot b vector, can it be written as ab cos theta, only we want magnitude. So for magnitude we removed this arrow direction, ab cos theta. Just substitute value. Let's say there is a box. We are visualizing this example. There is a box, and on this box force is being applied in this direction with I would say 10 Newton in this direction horizontally, and displacement, let's say it covered a distance how much, 5 centimeter. Now look at over here, this f displacement, so f is how much, 10, displacement is how much, 5. Angle is what is angle between these two vectors? What is angle? So angle we will say distance, it is covering horizontally distance, and force is being applied horizontally. So can we say that theta rotation is 0? The rotation is 0. Now it is coming completely. So cos 0 degree is equal to 1. So finally you will get 10 5s are 50. It is not with direction. This is only magnitude. That's why a quantity which is providing only magnitude will be known as a scalar. This is our answer. When you will multiply this force by displacement, you will get a scalar. Okay, only magnitude you will get. With example, I told you this thing. Okay, I hope this part is enough. Now let's see let's say one thing little bit different from this part. From this part. First of all, we need to draw a Cartesian plan so that we can get more clarity without having any kind of a doubt. So I am going to draw it. This is our I cap, this is our Z cap, and this is our K cap. It is known as 0, 0, 0. This is our origin. Now tell me, what is the angle between this I cap and J cap? You would say 90 degree. Where this J cap is a perpendicular to I cap. So this is forming a 90 degree angle. Is it happening? With the help of this formula, when we are multiplying these two vectors, this will be equal to AB cos theta. AB cos theta. But remember, when you are in the discussion of a vector product, I would say cross product, then this cos theta will become sin theta. Okay, you will see. Perhaps you will see. Okay. This formula will come a lot of time. That's why I would suggest remember this during this lecture so that you cannot get any kind of confusion. Look, this I cap is a vector, and this type of I cap is known as a unit vector. Can you say I cap is a vector? Yeah, we can say. So this is known as unit vector. Now what if we take a same double times same vector, okay, same vector, I cap again I cap, and we are going to multiply it. So I cap dot I cap. What will be our result? After multiplying this two vector, what will be result? Direct I can say 1. But what is logic? How did 1 will come? How will 1 come? We will have to tell the reason. If remember whether if these two vectors are along to its set, so we can say this a I 1 multiple 1, magnitude of this will be 1, magnitude of this will be 1. So 1 multiple 1, and then cos 0 degree will be 1. So finally, so magnitude of this I cap, always remember we have a unit vector, so magnitude will be 1. Magnitude will be 1 always for your answer. So magnitude of this will be of this vector will be 1. Will be 1, and magnitude of this will be 1, and cos 0 degree. Cos 0 degree. In that case, we are going to get 1. Same it will happen when you are taking Z cap double times. So again you will get 1. Same it will happen with the K cap. Again you are getting 1. This will happen when theta is 0. All this will happen when theta is 0 degree. Okay, when theta is 0 degree. But what if theta is 90 degree? One vector is parallel to another vector. No, this is incorrect. One vector is perpendicular to another vector. In that case, what is going to be our result after multiplying those two vectors? Okay. So I would say over here, let's take a different. This I cap, this I cap. Okay. Now Z cap, Z cap, I cap, Z cap. Both are different. Both are not same. So magnitude of this first vector will be 1. No problem. No problem. No problem. Magnitude of this J cap will be again 1. Cos 90. Theta is how much? 90. So value of 90 is going to be 0. 0. So this whole term will become 0. Will become 0. Same it will happen with the whole another another axis. Z into k cap, result would be 0. K into z cap, result would be 0. Z cap into j cap dot I cap, result would be 0. Okay, all this will happen when theta is a 90 degree. When theta is a 90 degree. Okay. Remember these points? There are some questions based on this concept. Let's take some question. First is 2 I cap dot 2 I cap. So as you know, magnitude of this unit vector is a 2 multiple this magnitude of another vector. Magnitude of another vector is also 2. Is also 2. Now cos cos 0. So this will be our 1. Here we can find the theta. If a question is not providing value of angle, we can still find angle value of an angle. Here both vectors are one vector is upon another vector. So rotation is nothing. Rotation is 0. So cos 0 will be 1. So finally you are getting 4. That is how a question will come. Look at over here. 6 multiple 3. 6 3 is 18. What about cos theta? Cos 0 degree is 1. Cos 0 degree is 1. Now next. I have these two things are clear. Here we are multiplying. Direct multiplication. Look at over here. Another question, it is a little bit different. There are two vectors, okay? Location of this first vector is given in this way. It is saying 7, 7 on positive x-axis, 2 upward y-axis, and 3 in front 3 unit how much front. That is how we communicate with the given this type of a vector. So location, this is given location of this a vector, this is given location of this vector b. Question is saying do multiple this two vector by using a scalar product. 7i cap plus 2j cap plus 3k cap dot 2i cap minus 3j cap plus 2k cap. Now you have option, either you can multiple all these terms like this, 7 by 2, then again 7 by 3, again 7 by 2, then take this term 2 and multiple this by all these three terms, then add take this and multiple this by all these terms. That is your first option. A smart way to solve to multiple this, I have another option, which is, as you know, if you take same vector, in that case we will get 1 and different will provide us a 0. So this I and I, so 7 to the 40, 7 to the 40. Now you would think that okay, this is done. Now let's multiply this by this. So here vectors are different. This I cap and this is j cap. In that case, we will get 0. So why should we take this 0? Now next you can multiply this by this by this. Okay, 2 3 is 6 minus 6 plus 3 2 is 6. So at the end you are getting 14. 14 is the magnitude. This 14 is a scalar. It is not with a direction. So dot product of vector A and vector B would be 14. That is how you will solve this kind of a question. Now next. Now in this question we have to find angle. Find the angle between the two vectors. These two vectors are given over here. So location of this first vector is a 3 I cap, and location of this b vector is a 4 j cap. 4 j cap. As you know, our formula is this AB cos theta. AB cos theta. AB cos theta. Look at over here. When you will multiply this by this, you will get 0. Why? Reason is we have different axes which are perpendicular to each other. That's why this will become our 0. Magnitude of A we don't know. So magnitude of A is 3 and magnitude of B is B vector is 4. Cos theta we don't know. This 0, 4 3 is 12. Cos theta. When this 12 will come in this side, this will become again 0. So cos theta is equal to 0. As you know, what should be angle over here, which will give us a 0 value. So 90, I think 90. So cos 90 is equal to 0. So finally we got theta as a 90. This is our answer. This is our answer. Okay. 90. That is how you will solve. This part is done. About a scalar product. Now let's explore in details about the cross product. Cross product. We will take two thetas. First theta will be 0, then theta will be 90 degree. Theta will be 90 degree. Look at over. But remember one thing I would say over here. When you are taking cross product, in that case this A vector cross B vector will be AB sin theta. Okay, AB sin theta. When you are talking about a cross product, then this will become sin. This will become sin. Okay. Now there is no problem. This was not problem. It was a point to analyze. I would say to analyze. Now first of all let's take same vectors two times. This I cap cross again I cap, and theta we are taking theta of course automatically we are getting, which is 0 degree. 0 degree. Both are along a line. Both are along a line. That's why 0 degree. Rotation is 0 degree. So magnitude of this first vector is 1. Again 1. Sine how much? 0. So this is going to be 0. It will happen with all another axis, but condition is two axes should be same. J cap multiple J cap. Result would be 0. K cap cross K cap. Result would be 0. All these three will happen when theta is 0 degree. When theta is 0 degree. Now let's take different. I cap multiple J cap. Here, if you use this formula, this is a half incomplete formula, I would say. At the end, you will get only a magnitude. But what about the direction? As we said that when we will be multiplying a two vector, then a result would be a vector again. But if we use this formula, result is coming. Result would be a scalar. How will it be possible? So it will become possible when we will use direction. Direction. So for direction, we are going to use this n cap. We are going to use this n cap. Okay, n cap. Here you can see direction on this Cartesian plan. Two types of direction you will observe. First, clockwise, and second, anti-clockwise. Anti-clockwise. Two types of direction. Clockwise, like that, and anti-clockwise, upward. Clockwise downward and anti-clockwise upward. Okay. When you are going clockwise, then your direction will become negative. When you are going anti-clockwise, then your direction will be positive. Positive. Okay. This will be our negative, and this will be our positive. This was about the direction. Direction. This was our direction. Now look at over it. In this case, all things a result was our zero. Okay, zero means zero, nothing. Now we took this two different factors, different axes. I would say different axes, I cap and j cap. I cap and j cap. Angle would be 90 degree. Both are perpendicular to each other. So magnitude of this first vector is going to be 1 cos again 1 sine 90 and n cap. I will tell you what is the n cap. N cap is nothing but it is a next. This is going to provide next axis, which will not present in this vector. Okay. So 1 is 1 and sine 90 it is going to be 1. So finally you got how much? 1, and this n cap is nothing but this is your k cap. This is your k cap. Okay, same it will happen with other positive k cap. Now j into I cap. So this is our j and this is our I. So like that we are going clockwise. Direction is clockwise. So result would be in negative 1, and then next axis is coming, which is k cap, but this is in a negative. This is in a negative. Now next we have I cap into k cap. I cap into k cap. This I cap, then direction is like this. It means negative j cap. J cap into k cap. J k. Direction is like this. Anti-clockwise means positive I cap. Positive I cap. Positive I cap. So all these are n cap. Okay. All this will happen when theta is 90 degree. When theta is 90 degree. printed as 90 degree. Oh, this is simple. Negative, positive are important to apply. Now let me take question. Let me take a question. This first question, vector A is 2I cap plus 3j cap plus 3j cap. Vector B is equal to 4I cap minus 3j cap. Now let's solve this. We have to solve this by using vector product, by using cross product. As you know, this A into B cross A vector cross B vector is going to be A sin theta n cap. So it is going to be how much? So let's say we have 2I cap plus 3j cap cross 4I cap minus 3j cap. We have again two options. If you say it here, this we were solving this question. First of all, we have two options. Again, I want to repeat those two options. First, you have a first option which is like that you can multiply this 2I, this first term by these two terms. Then in the next step, this is second term by this two term. This is your first option. Next option is, which is a smart option, I will say. Tell me, if you take in the discussion of cross product, if we take same data, so what is going to be our result? Our result would be 0. No, 0. 1. Yeah, 0, because sine 0 degree. 0, yeah. So I cap, again I cap, 0. It is going to be 0. So that's why we can ignore this same vector. Okay, same vector we can ignore because our result is going to be 0. Instead, you can take what different vector. 2I cap and this 3j cap. So plus minus 2 3 is 6 I into j cap at a 90 degree angle. It is going to provide the next axis, which is a k cap. Okay. Next term we have this 3j. So this 3j cap and this 3j cap will be 0. That's why we can ignore this thing. Okay. Instead we can multiply this by this 3j cap 4I cap. So 3 4s are 12. 3 4s are 12. So IJ next would be K. One thing I would like to suggest over here, I then J. It means it is going clockwise. This is going clockwise. I J. So here direction, this will become negative. It was already negative and direction is positive, so positive negative will become negative. Now in this case, this 3j and this 4j direction, look at the direction, j then I, again it is, so this will become our negative, because direction is clockwise. That's it. Direction is clockwise. So finally, this your answer is correct. Here one thing we noticed, which is direction will matter. Direction cannot be ignored. If we are rotating in clockwise direction, our result would be with a negative. If we are Whereas if we are going anti-clockwise, then result would be with a positive. Okay, positive. Have a look for few seconds. Now let's understand next topic, which is regarding motion in a plane. I'm going to erase this thing. Look at brother over here. In this Cartesian plan, I am telling you one thing. I am giving you one thing, which is the location of a particle, and I also gave you a location, exact location with the coordinates of 5, comma 2, 5, comma I would say 4. What are you understanding by these coordinates? By these coordinates, you are understanding that according to origin, this particle covered 5 unit along x-axis and 4 unit along y-axis. This is what we are understanding over here. I would say you are correct. That is how we communicate with this given coordinates according to this origin. We found location which is a 5, 4. But in the language of a vector, it is said that this will be written in the 5 I cap plus 4 j cap. Location of a let's say day vector. Location of this particle. We are interacting with this like that: 5 unit along x-axis, 4 unit along y-axis. Can someone say that this particle is moving at the same time it is covering 5? It is covering 5 in x-axis. At the same time it is covering how much? It covered how much? 4 upward. It went x-axis with 5 unit and it went upward with 4 unit. 5, 4. This particle covered at the same time. Means this particle is going horizontally also and vertically also. Horizontal and vertical with the same time. This is what is happening. We will have to observe carefully. Then we will observe that yes, this is happening. Okay, means 5 this unit and 4 upward. Same I would like to tell you over here. This I cap, j cap. Instead we take a straight line. I am giving you a stone, a material, A of Z. Stone was thrown. Okay, stone was thrown like from here, and it went like this. It is not a straight line. This is a curved line. Curved line of motion of a stone, which I gave you to throw. When you throw this object, so this motion of this stone is like this. Is like so. This motion, this object started doing motion from here, and it stopped over here. Starting motion is over here and ending motion is over here of this stone. Are you understanding? What is this? This is a curved line of a motion of a throwing a stone. Throwing a stone. Now, what if velocity is given? Velocity is given. Question is saying the stone was thrown with a hundred velocity. With a hundred velocity. With this much velocity, it was this stone was going horizontally and vertically, both. With how much velocity? With 100 meter per second. With this much velocity, a stone was going horizontally as well as vertically. Question is, we want to get a horizontally, how much it was taking velocity? Horizontally, only horizontally. After getting horizontally, with how much velocity this particle was going vertically? This two things we want right now. These two things we want. Okay, so to get these two things, we will have to use one thing. X sin theta, y cos theta. X sin theta and y cos theta. So this for horizontal we use x sin theta. Okay, x cos theta. For horizontal, x cos theta. Remember, x cos theta. Clear? So inclined angle is how much? 53. Remember, angle rotation of this throwing stone is 53. 53. So remember, for horizontal we use this x cos theta. For vertical we use y sin theta. Y sin theta. Y sin theta. Y sin theta. So just put this x is what? 100 and cos 53. You will get something. Put over here 100 and sin 53. Whatever value will come by this equation, this will be your 60 meter per second and this will be your 80 meter per second. After solving this thing, you are going to get 80 meter per second upward for upward and 60 meter per second for horizontal. For horizontal. Remember, for horizontal, we use this x cos theta, where x is this much velocity. For vertical, we use y cos theta, where value of y is same 100. We use these two things to calculate only one velocity. It can be for horizontal, it can be for vertical. If you want a velocity which is going horizontally, we will use this thing. If you want a velocity which is going upward, we will use this vertical y cos theta. Okay, not cos, this is sin theta. Did you understand how this thing came? How this 80 meter per second came? Yes, these two things came from these two things. From this 2 point. Now try to understand what is the meaning of this 60 meter per second and 80 meter per second. It is telling you this stone is going with a 60 meter per second horizontally, only horizontally, and it is going upward at the same time with 80 meter per second. We found a different separately velocity for this motion of a stone. Remember, if acceleration is not given by the question, okay, acceleration is not given by the question, one thing you can do, which is acceleration for horizontal will be always constant, 0 you can say. So velocity is going to be constant. Horizontally, I am talking about horizontally. So what is the, if someone asked to you what is the acceleration of this stone which is going horizontally, in that case you would say acceleration is going to be 0. So if acceleration is 0, so velocity will be constant. Constant means this is a 60 meter per second, which is a horizontal. So over here is a 60 meter per second. So at t is equal to 4 seconds. This is again is going to be 60 meter per second. At each time, this velocity is going to be same. Same here, 60 meter per second. Same here, 60 meter per second. This thing will happen when question is not giving you acceleration, value of acceleration. Okay, value of acceleration. And remember, it is in air. This stone is in air. We found acceleration for horizontal, for vertical. Acceleration is going to be z. G means gravitation, force, gravitation. So it is also constant. I didn't say 0. This is going to be always minus 10. It is constant. Okay, this is constant. It is for forever. Okay, minus 10. So acceleration vertical downward will be our minus 10. Now tell me one thing, David. Let me write this over here. For vertical, acceleration is going to be z is going to be minus 10. Why minus? Because it is a downward, that's all. This is a downward. Okay, no problem. Now questions are coming from this concept. Questions are coming. Questions are coming. Here t will be 0, isn't it? Initially, at initially velocity, this t is going to be 0. This is where stone was thrown. At t, at t is equal to 0, velocity is how much? 80 meter per second. 80 meter per second. As the stone went upward, a little bit upward, then velocity decreased. Velocity decreased. Again, it covered some more distance upward. Then velocity will decrease more. This is happening. This will happen. It is happening because acceleration is minus 10. Acceleration is minus 10. Okay, minus 10. That's why this is happening. But when it comes to horizontal, so remember, velocity for horizontal is fixed. Acceleration is 0. Acceleration is 0. So velocity is fixed. After at t is equal to 4, velocity will be same. At t is equal to 2, velocity will be same. But when it comes to vertical, then velocity will decrease. As the particle will be going upward, velocity will decrease. So t is equal to 2. At 2 second, velocity will be, so acceleration is 10. So 10 into 2, 20. At 2 second, 10 into 2, acceleration would be 20. So 80 minus 20, velocity will become 60. At t is equal to 4. At t is equal to 4, velocity is going to be, acceleration is minus 10. Acceleration is minus 10. Minus 10. So tell me, this will be your minus 60 meter per second. Time at 4 second, acceleration is minus 10. So minus 10 multiple 4, 40. So at 4 second, acceleration is becoming of 40, minus 40. And initially velocity was 80. So 80 minus 40, it will become your 40. It will become your 40. Okay. Now t is equal to 6. Over here, acceleration is 10. So at 6 second, acceleration is going to be minus 60. So 80 minus 60. 80 minus 60 will be our 20. At 8 second, velocity is going to be 0 meter per second. 0 meter per second. This is your pattern. Try to understand this pattern. At 0 second, velocity was 80 meter per second. At 2 second, velocity it decreased by 20, which is 60 meter per second. At 4 second, velocity we got 40 meter per second. It decreased by 40. At 6 second, velocity became 20. At 8 second, velocity became 0. This is where we will get h maximum, height maximum. So maximum height of this stone which went upward. So maximum height was this maximum. I am talking about this maximum. So over here our velocity is becoming 0 and time is 8. At 8 second, velocity is becoming 0. Velocity is becoming 0. Now tell me, you have understood how to calculate velocity. Okay. Now let's say time of a flight. Time of a flight means how much this stone took time to stay in air, with some velocity. So you would say 12, not 12 but 16. From initial to half, it took 8 seconds. So again, this half will take same 8 seconds. So finally, 8 plus 16, 16 seconds. So this stone took 16 seconds to stay in air. That is how you will find the time of a flight of anything. Okay. Time of a flight. Now let's explore more about H maximum. We know velocity is 0, but what is this displacement? We want this displacement. For this, we can use third equation of motion, which is equal to v square, u square minus minus 2a h maximum. U square minus 2a s. You will use this formula when velocity is becoming 0. So from this you will get your this displacement from ground till the maximum height. So u is initial velocity was 80 square minus 2 multiple acceleration was minus 10 h maximum 80 0 1600 plus 20 h mx minus 1600 upon 20 h maximum height. 80. So this is a 64 minus 370 this is already your minus. So you will get a maximum height how much? How much? 320. So this is a 320 displacement from ground till the maximum height. So you will get this displacement when this formula will be used. Third equation of motion. Now how to find range? range. How to find range? Range is nothing but, as we found this displacement which was from ground till the maximum height. Same with range. Here we take a displacement horizontally from initial till the that place where stone came to the rest from here to till here. So this displacement we are talking about. In that case, acceleration is 0 and time is 16. In initial velocity is 60. So of course we can use same formula. This same formula UAP. Simple, brother. For range, I would say if acceleration is zero, I would say just multiple this velocity and by time. So 60 multiple by 60 will be your range. 390. 960 is your range from here to till here. You got this much range just by multiplying initial velocity of x by time, by total time. If acceleration is given, then you will use a formula of motion. That's all things we understood. Now, in the language of a vector, you can say, in the language of a vector, you can say in the language of a vector, you can say like this. Over here, t is equal to 4. T is equal to 4. At 4 second, velocity is 40 meter per second. 40 meter per second. But hold on, this is a Vx velocity. So why Vy velocity will be 40 at 4 second. So 40 meter per second at 4 second. At 4 second. At 4 second, V at 4 second, V x is going to be 60 meter per second. Vy is going to be 40 meter per second. 40 meter per second. Okay. In the language of vector, you can say position vector. Position vector will be your 60 I cap plus 40 z cap. 40 z cap in the language of vector. Okay. So this vector will be your at t is equal to 4 second. Vector this velocity is going to be same 60 I cap plus 40 z cap at 4 second. This is also your position vector. This is a simple vector. Now here I want to tell you one more thing. What if I ask you, tell me coordinate of this point. At t is equal to 4 second. Coordinate. what will be coordinate? What will be coordinates at 4 seconds? There is a method to calculate this thing. Method is first x then y. Tell me, here we are finding location, okay, location of x, location of y. So for this location we do simple thing, which is what is the velocity, how much velocity, 60 on x, along x axis 60, and multiple this by time, so time is how much, 4. This will be your x, this will be your x, okay. Now for y, so y is how much, 40, and time is 4 seconds. So 40 multiple 4, this will be your y. We are saying 240 comma 160 is equal to, coordinate of this is 240 comma 160. 240 unit along x axis and 160 unit along y axis. But in the language of vector we say 60 unit along 60 unit I cap and 40 unit j cap. Both are different. This is a sum of a vectors and this is a coordinate. That's why we will say both are different. Both are not same. That is how you will calculate coordinates, and that is how you will calculate location of any velocity.